I am projecting my voice. I am projecting my deck. I'm ready to talk to you all. I'm really happy to be here talking to you all. So, yes, my name is Seth Eliot. I'm going to talk to you about DevOps in the cloud. Now, I personally learn best when I'm given examples. You can give me like this big abstract description of something, and it doesn't click. So I like learning by example, by use case. I'm going to share use cases that I've seen at Amazon.com. Now, I've been with AWS for about 4 years, but for 8 years before that, I was on the .com side working with teams across the company, and that's how I've come to know these examples. And oops, you have to turn on the clicker. Boop, boop, there. So I have a hobby in addition to my day job at work. I consider myself a little bit of a technical historian of Amazon tech. So I created this internal wiki page that shows the Amazon page throughout the ages. This is Amazon in 1995 when it was founded. And then I collected a bunch of others and put them on this page so you could see the evolution. So I like collecting things like that and collecting things about the technology of how the technology and culture at Amazon evolved. So that's where we're going to start. We're going to start at the beginning, 1995, and talk about Amazon.com, the DevOps culture there, and how it's resulted in processes and technology that result in resilient services. So this is the amazing architecture of Amazon in 1995 when it went live. You see that box that says Obidos? Well, first of all, Obidos is a place in the Amazon River. So Amazon River. That's the narrowest and swiftest part of the Amazon River. And that was the name of the web server, the binary, a C, not C++, a C binary running on a single server talking to a database, a single Oracle database called Amazon.com Books running on another single server. So 2 servers running all of Amazon.com when it went live. You can see there's a person there, there's the internet, there's a package being delivered from the distribution center, which later we became fulfillment centers. And then there's the credit card motel, which is sort of a separate thing that was to keep credit card numbers safe. I remember when I started in 2005, people, in order to work on that, needed to badge into a special room. You couldn't even remote in to work on that. So that's a monolith, right? A C eventually became C++ monolith. And monoliths are okay to start, but it grew and grew and grew, and all the business logic was in there, and became very unwieldy to work with, right? So everybody who made any changes whatsoever all had to make it to the same build and deploy at the same time, and it was just unwieldy, not very agile. And I found a page from 2000 that was telling folks how to build Obidos, the big monolith, on their own dev box for testing. You made a change, you want to test it. Took 12 hours to build. Okay, so that's not tenable, that's not going to work. So let's fast forward a little. 1998, the very first engineer that Jeff Bezos hired, a guy named Shel Caffin, wrote a document called the Distributed Computing Manifesto. And it had these radical ideas like, let's separate the business layer and the data layer and the presentation layer. Or let's set up APIs that are well-defined and hardened. So that was a booster that got engineering teams thinking, and they eventually split out services, created the customer service, the item service, the order service, started to split these things out. Now, in 2005 or 2003 is when Garupa launched. Now, Garupa is the fanning out of the Amazon River. So there's a little bit of a poetry here, right? Obidos was a bottleneck, narrow, swift. Garupa was the fanning out of the river. And Garupa was to replace Obidos. And the way it did that is it was a rendering engine that would call back-end services called widgets. At the time, we didn't call them microservices. I don't know if anybody was using the term microservices. They were widgets that each do a different thing on the website. We'll call hundreds of these to assemble the page and display it. And by, what was it, 2006, it had completely replaced Obidos, and the switchover was complete. But fun fact, I checked the Garupa deprecation page. There are still pages on Amazon.com running on Garupa, and final deprecation is scheduled for the end of 2023, so we'll see if that happens. I'll get back to you on that. All right, so this is a page on the Amazon site. I think you've all seen pages on Amazon and what they look like, and when you go to buy things, this is for the Fire tablet. And this, as I said, is an example of it's Garupa, as I said, Garupa is being deprecated, but it's still the same principle, which is if I run an internal tool, I could show you something like this. All right, this is showing how each thing on that page is being, the business logic is being handled by a separate microservice. There's an image service, there's a title service, there's even an average reviews service, hundreds of these services running. So these microservices, this is basically a microservices architecture. And the advantage of this, okay, so throughout this talk, when I have these kind of yellowish boxes, this is me now tying things back to DevOps, right? So what's the advantages here? So independent development and deployment, right? We all appreciate how that could be an important productivity booster. Each team owning its own little widget or widgets on the back end, being independently deployed from other teams. Increased resilience. Now, as Mark said, I was a reliability lead. Resilience is a big deal to me. Increased resilience using something called graceful degradation. What do I mean by that? Well, we agree that the title and the image and the price are all really important. But let's say the average review service was having a failure. Well, it would fail, and that would not show up on the page. Now, the consumer, would get a degraded experience, but it's a graceful degradation in that you still get everything you need to make a purchase. You just don't see the average reviews. So in this way, the non-critical services can independently fail or have issues, and still the user gets a usable experience. The system remains available. That's graceful degradation. And then enabling teams to do more. This is one of my favorite things about DevOps, is using the specialized teams and platforms that enable the teams. So there's a team that owns Garupa, and they build it and they maintained it, and there's teams that own and maintain the things that replace Garupa. And the widget owners now don't have to worry about all that sort of heavy lifting of getting things on the website. They just have to worry about interfacing with the platform and writing their business logic. So it's taking that weight off their plate. And so this is now the architecture in 2023. Each dot on that diagram, believe it or not, is a service or microservice, and the lines connecting them show the lines of dependency. And you look at this and you think, that's insane. That's like tens of thousands of services. That's nuts. How could that possibly run? How could Amazon possibly be still up? You check right now, is Amazon up? How could it possibly be up when it's that complex? And even I'm kind of stunned by it. I mean, I have two answers. One is it just works, but it just works because of the culture and the way Amazon is organized. And one of the real keys behind that is the two-pizza team. Who here has heard of the two-pizza team? Right? Amazon's been blabbing about two-pizza teams for years and years and years and years. Right? It's a team that can be fed by two pizzas, so roughly between 5 people and 10 people, somewhere in that range. Right? It doesn't have to be exact. But the more important thing, more important than how many pizzas they're eating, is what it means to be on a two-pizza team. Number one, it means it's a team of multidisciplinary builders. It's developers, it's QA, it's designers. Right? But they also have ownership and autonomy over the services that they own, which means they get to choose the tech. Right? So now, don't get me wrong, there's certainly incentives to choosing certain technical paths at Amazon. There's certain things that are centrally supported. There's certain things that have preference over others. But if the team decides they're going to use Rust or whatever, that's up to them. If they could justify that, they can use it. And the other thing about ownership is they build it, they run it. So just to be clear, a two-pizza team owns the design, the implementation, the deployment, and the operation of their services, end to end. So this really is a DevOps model, right? It's the DevOps culture of collaboration and ownership, right? So they were owning it right there. And the culture and the collaboration and shared goals. So like we talk about breaking down the wall between dev and ops so that the people working on it have shared goals that are both development goals and operational goals. This is one possible model for that. Now, is it the only possible model? Not at all. Do I say all teams need to own everything end to end? Not at all. This is just the Amazon model. It's one of many models that breaks down that wall, but it does indeed break down that wall. And I want to emphasize, and you've probably heard other people here say it, I have, DevOps really starts with the culture. You could talk about the tools, you could talk about the actions, whatever, but really DevOps is about culture. So I want to talk to you a little bit about Amazon culture. Amazon has 16 leadership principles. Who's heard of Amazon leadership principles? Yeah, you've heard, again, Amazon won't stop talking about this. You've heard of it. Even if you didn't raise your hand, you've heard of it, right? So these are 3 of the leadership principles I put down for you, and I want to map them to sort of DevOps type things. So customer obsession. You start with the customer and you work backwards, maps really well to the DevOps principles of delivering value to the customer reliably and quickly, right? And I'm going to tag this at 1995 at Amazon's founding. Now, insist on high standards means many things. Amongst the many things it means a continuous, a culture of experimentation and learning, right? That's a DevOps thing. And I'm going to tag this to 2003, because that's when Amazon started doing game days. And in these game days, they simulated shutdowns and faults, including up to an entire data center. I was a service owner at the time, and I went through that, and it was quite an experience. And ownership, that's another leadership principle, and I'm going to tag that to before 2005, but 2005 is when I started at Amazon, and 2005 is when I was handed that pager, and I learned, yes, you're going to own the system in production. You're going to have a week, you know, every few weeks you're going to be on call and responsible for the system in production. Now, the interesting thing about it is I keep calling it, mapping it to DevOps, so all of these things precede the term DevOps. And all of these things precede the term chaos, as in chaos engineering or chaos experimentation, which is why I think that at Amazon, they don't internally talk about DevOps that much. They don't say we're DevOps or we're doing DevOps. They say we're Amazon. We're doing the Amazon culture. My point here is the Amazon culture is a DevOps culture. All right, so you saw the case study of Garupa and the page rendering. Let's dive into another case study, and we'll go into a little more detail here. This one's going to be on chaos experimentation and how specialized teams and platforms help teams do more. And this is the story of Amazon Search. I'm not going to have you raise your hand. Have you used Amazon Search? I know you have, right? To find something on the site. And I'm going to search for chaos engineering. And searching for chaos engineering, oh, there's over 1,000 results. Search is a large-scale, complex, distributed system at Amazon. It's serving 300 million customers, 84,000 requests per second at peak at Prime Day 2022. So it's doing a lot, it's complicated, it's high scale, and Amazon wants to keep it reliable and available for customers. So zooming in on this book, Chaos Engineering by Casey and Nora, definition of chaos engineering is the discipline of experimenting on a system in order to build confidence in the system's capability to withstand the turbulent conditions in production. And what that means is with chaos engineering, this is not a chaos engineering talk, so really briefly, what you're going to do is come up with a hypothesis based on your design that if this fault were to occur, or if this loading event were to occur, my system would react in this way in order to stay available, and then you're going to simulate that. You're going to simulate the fault, you're going to simulate the load, and observe how your system responds. That's chaos engineering. And in Search, this is about dedicated, specialized teams and platforms. They have a specific team called the Search Resilience Team. They're an operational excellence engineering team. They're engineers, they build stuff. And their main mission is driving the resilience of the Amazon Search platform. Now, Search consists of over 40 back-end services. So as, you know, just like all these other service-oriented architecture, there's 40 back-end services, each owned by a team, and then there's also this resilience team. And we're going to focus on how this resilience team wanted to enable chaos engineering and make it easier for those 40-plus teams. So they built the Chaos Experimentation Orchestrator. Now, there's a lot to look at here, but what I'm going to focus you on here is the right side, where they have that big arrow showing Amazon Fault Injection Simulator. Fault Injection Simulator, it's AWS Fault Injection Simulator, by the way. So Fault Injection Simulator, or FIS, is a built by AWS service that lets you run chaos experimentation. So we're good, right? Well, we don't need the resilience team. We don't need an orchestrator. We have a service. Well, I'm going to show you why they built what they built. But FIS is a fully functioning fault injection service that lets you, that works with AWS services, and it was a good fit for Search, because these 40-plus services are all running on AWS. If you can see on the right where it says EC2 and ECS, those are some of the services they're using, so they're going to use FIS to inject fault into those services. But on the left is where the orchestrator sits. I'm going to show you where those three lambdas are, where it says orchestration workflow. This is so they can actually put steps before and after the fault injection. So they have search-specific requirements that they're trying to do with their fault injection. So before they run a test, they're running their fault injection in production, by the way. But before they run it in production, they're going to run it in a test environment or a pre-production environment. That's the way to do it. So that workflow actually checks that. So before it runs anything in production, it says, hey, did this same test run in pre-production and did it pass? So I'm going to check that. It might be checking things like, is there a company-wide event going on, like a negative event? Because we don't want to do chaos engineering when there's any kind of issues going on. The post-chaos, then it's going to inject the chaos, and then the post-experiment step might be something like, let's file a ticket and record the results of what happened. So that's the orchestration system. But they're actually trying to meet multiple requirements here. They want to make this scalable across 40-plus services. So there's fault injection simulator in the center, and the orchestrator actually works with other things too. There's an internal load testing tool at Amazon. It works with that also. So it lets them do all kinds of things other than fault tests. It also lets them do load tests. But how do they actually want to, what is this orchestrator actually doing to help them scale to 40 services? Well, number one is providing an easy set of APIs that any search team can use to run experiments, and putting a graphical UI in front of that, so it makes it really easy for them to see what's going on and use it. Running on a schedule. FIS natively allows you to integrate with EventBridge to run on a schedule, and that's in the documentation. But rather than have every team create that integration, instead, the search resilience team made it part of the orchestrator and made it part of the APIs and the UX, so made it easier for the teams to all just onboard onto. Similarly, running chaos tests with deployment, running them as part of your pipeline. Again, supported integration with FIS, but internally Amazon uses its own internal pipeline system, so they wrote all the little code, all the code to link that up and make it work with those pipelines really easily. Okay, this one's my favorite. Guardrails using SLO, so I need to explain what guardrails are. If you're doing chaos experimentation, it's crucial, it's necessary that you have guardrails. Guardrails are quantitative metrics you're measuring that tell you if the experiment's starting to go off tracks, if the experiment's starting to have impact on your customer. You don't want that. And if that happens, you stop the experiment and roll it back. It's a guardrail. Now, FIS supports this. They have something called stop conditions. But the search-specific requirement here is to use SLOs, or service-level objectives. Each team in search is required to have one or more SLOs. The search resilience team built a separate system for storing and tracking those SLOs, so now it makes sense just to match those up and use those SLOs in the SLO system as the guardrails in the chaos experimentation system. Andon cord. Andon cord was invented at Toyota in their factories. Anybody on the line could pull the cord and stop the line if there was a quality issue. Same thing here. There's a big red button. Anybody in search can stop all experimentation. And metrics and insights roll-up. Of course, FIS supports logging and metrics, but they wanted to create reports specifically for search leadership of search experimentation, so this rolls that up into those reports for that leadership. And the types of faults they're injecting using FIS, they're doing things like, as I said, they're running containers, so draining the containers from an instance, or killing an instance, or injecting latency, or black holing a port. These are the kinds of experiments they're running using FIS. Now, I said there's other experiments they're running too, like load generation, right? That's another kind of experiment they run. I want to talk about another kind called emergency lever activation. So emergency levers are interesting. This is an Amazon process by which they create an easily automatable process that helps your system if your system's under duress. If your system's under duress, it's starting to brown out, you pull the emergency lever and it has immediate positive effects. So for instance, I know the front end has an emergency lever to stop all robot traffic and prioritize real customer traffic. That's an example of emergency lever. The emergency lever that search is using amongst many is a different one. What they did is this. So this is search results for Lego that are normal. The emergency lever has not been pulled, and you can see it's pretty rich results. You're getting pictures and descriptions and prices, all that good stuff, right? Now, if systems under duress, what they want to do is shut down non-critical systems and leave the critical systems running and give the critical systems all of the resources that are available. So it looks like this. Okay, now the average rating has gone away and some of the descriptive text has gone away, but you could still you're still getting good search results. Again, this is another example of graceful degradation. So they pull that emergency lever, and this is what happens. So you could run chaos engineering tests around this. You basically load your system and pull the lever, and you expect to see you load your system until there's some duress, and you pull the lever, and you expect to see that duress go down. So that is one of the kinds of chaos experiments they do. I also wanted to mention Prime Video, the video streaming service. They're also doing chaos engineering. They actually were doing it before FIS was launched. So you can see here they started building their own tools, creating their own communities around it. And just like Search, they have a dedicated team to building tools and supporting that chaos engineering effort. And this is an interesting slide because this shows the kinds of faults that Prime Video is injecting. And the bars represent how often they're injecting those faults. And this data, how often they're injecting, is based on observations of production. Looking at production, what kind of faults occur most often and have the most impact? Those are the ones we're going to run the most. So as you can see, packet loss is a big one. That makes sense for a video streaming service. All right, so in summary, we talked about chaos experimentation and how it was enabling teams. And just to be clear, you create this search resilience team is not doing the chaos experimentation for the 40-plus teams. It's creating the engineering and platforms and processes so they could do it themselves. I think that's really a very DevOps thing, and that's why I say it's about enabling teams to do more and through specialized teams and platforms. But this is also about continuous experimentation and learning. It's also about continuous integration, because you could hook up those experiments to your pipeline. And it's also about increased resilience through, again, graceful degradation. All right, next case study. Responding to customer impacting issues, delivering value with cooperation and ownership. So if there's a customer impacting issue, how do you respond? What's your processes? And what is your tech to help the customer out? In this example, unlike everybody's heard of Amazon Search, I bet you nobody's heard of the Amazon Relay app, right? You've heard of this? You can download it today if you have an iOS or an Android phone, and unless you're a long-haul trucker, it's not going to do much for you, because that's who this app is for, is long-haul truckers. You've seen the big rigs on the road, the ones with the big Amazon swoosh on them, the 18-wheelers, right? You've seen those? Okay, it's for those truckers. This is not the trucks delivering stuff to your house. We call that last mile. This is for what we call middle mile. This is delivering stuff between the vendors and the fulfillment centers, or between the fulfillment centers. And Amazon has a very sophisticated model for what should be where at what time. These particular items sitting on this shelf need to be over there in order to meet the customer on time, right? It's a very sophisticated model. And I like to think of it as this is an abstract model, right? This is just numbers in the cloud until you put it in the hands of the trucker through this app. And this app tells the trucker, go to this fulfillment center at this time, use this code to get in the gate, pick up this stuff, and bring it over there by that time. It's really an amazing thing that take this model and make it real through this app. Well, December 2021, there was an issue in AWS in the US East region that caused several services to have issues, like SNS had an issue, and this caused a 30% error spike in the ability of truckers to know where to go to pick up their loads, load assignments. So it wasn't 100% failure, but it's still 30% failure is too big. This is customer impacting. The truckers are the customers in these cases, ultimately affecting customers that are receiving merchandise. So this is unacceptable. So what do you do? Well, what the team that owns the Relay app did is a COE, or correction of error exercise. Yes, AWS, their dependency had an issue, SNS had an issue, but the Relay app wants to understand how can we remain reliable no matter what. So they did a COE, and COEs are not finger-pointing exercises. They're not like your fault or you did this or whatever. They're deep dives to get to the root cause of an issue, and their ultimate goal is to generate action items. If a COE does not generate action items, it's a failure. And the action items are literally tracked in the COE tool, and you can see a snapshot of that tool on the right there. And we're going to focus on two of the action items. One is to do a study of what they could do to improve resilience, and then the next one is to actually execute on that study and apply what's called multi-region to maintain resilience, and I'm going to show you that. All right, so the resiliency review said we want to preserve physical operational continuity in all cases, even if the experience is degraded. All right, so you already see we're heading for a graceful degradation story again, right? But I liked how one of the devs put it to me. He said, don't let stuff pile up on the loading dock, really. That's what it comes down to. If there's stuff piling up on the loading dock, something's gone awry, don't let that happen. So they identified three main areas. There's a detailed report, I'm just giving you the summary, which is to identify what the critical functions actually are, make it so those critical functions are more reliable, and then make it so that the system can run without the non-critical functions. So focusing on item number 2, how do you design the solution to keep those critical functions reliable? They decided that multi-region was the approach. So as I said, they're running out of US East 1, so what they're going to do is run those critical functions in a US West region also. If you don't know, AWS runs multiple regions all over the world, so these are just showing you the regions in the US. And this is the design, so there's a little bit to unpack here, right? So you can see there's a little phone, the app, which is connected to Route 53, which is a DNS system. Now, the DNS system, Route 53, is going to send you either to the east region or the west region based on latency. That is a built-in feature of Route 53 that you can use. So when it sends you to the east or west region, it's sending you to a gateway service. So it's showing an API gateway there, which is used by that service, but it's more than just the API gateway. It's a gateway service owned by a team. And that gateway service exists in both east and west. And then there's about a dozen back-end services they call modules. You can see module A there has been updated so that it's running in both east and west. Module B, however, is only running in east. So what's going on there? Well, first I want to say that this is a totally decoupled model. So each module, as well as the gateway, do not share code, they do not share deployment, they do not share infrastructure. Completely separate and separately deployable. Module A is a critical service, like the load service that tells you where to go and what to pick up. That's a critical service. So it's in two regions. Module B was deemed a non-critical service. That could be like GPS directions, right? The app gives the truck driver directions, but if that went down, the truck driver certainly has other options for getting directions, so considered non-critical. So that was not made multi-region. And if you look at this, there's the ability to fail over. So if there's an issue in US East 1 that indicates there's something going on, maybe we're starting to see a little spike in errors or latency, they could fail over to West region. And what this means is that now, instead of latency deciding where the requests go, all requests go to West Gateway. And as the request goes to the West Gateway, look at Module A. For Module A, if it's a request for the load delivery submodule, it's going to go to the West region. And that's a critical service, and it's going to serve that request. If it's a GPS request, it's going to still go to East region. So what happens there? We failed out of East. Well, two things could happen. Just because we failed out of East doesn't mean East is hard down. That doesn't happen. Regions don't go hard down. So the GPS system might still be working in East, and all is happy. Or it might not be. And if it's not, that means we're still going to be able to deliver critical functionality to the trucker, just non-critical functionality will be affected for some time period. And then they tested it. You have to test it, right? So they built this in mid-2022. They want to be prepared for the big show, which is holiday season, or what they call peak, in 2022. So how do you test it? Pull the switch. In production, they did a failover. They failed over, so all traffic went to the West region. They saw a big spike in West traffic, which is expected. Nothing's going to East anymore. They saw no customer impact. They saw no system failures, no degraded experiences. Failover took about 10 minutes to execute fully, and they saw some latency increases. They were not thrilled with the latency increases, but they were within spec, and they're continuing to work on that to this day, to work on that. So overall, a successful test, and now they have the knowledge that they can fail over and remain reliable and keep those trucks rolling. So, the lessons here are around delivering value to the customer, a big thing in DevOps. So very customer focused, seeing that their customers are getting errors. How do we fix that? The COE, the correction of error, is all about, hey, we affected the customer. How do we address this? How do we fix it? Shared responsibility and ownership. I mean, a COE is all about taking responsibility. This is our system. This is what it did, and this is what we're going to do to fix it. And microservices architecture are always a good thing, right? Breaking things up into modules in the gateway. And observability. Observability is a big thing. You need to be able to observe that there's a customer impacting issue. You need to be able to observe what's happening during the failover. So observability is certainly a big takeaway here also. All right, so I showed you 4 examples. I showed you the Amazon detail page. I showed you Prime Video and search. And then I showed you the Relay app. There's a lot more examples like this all across Amazon, all driven by culture, which then results in technology. So the culture about independent teams and ownership results in these technologies like the search orchestration system or the Relay gateway and the failover capability and all of these capabilities that enable teams to do more. A bunch of resources here. The very top one is an interesting one because Amazon, about a year ago, published that distributed computing manifesto, that document by Shell. So you can go and read that for yourself. It's quite an interesting blast from the past. The second link there is a deeper dive. I only talked a little bit about how search does chaos engineering, so it's a deeper dive of that. And then a few other links I think you might find interesting there. And with that, I thank you. The code there goes to my tree, what is it, link tree. And on the link tree, if you can go there, there's a DevOps section that contains all those links I just showed you. So if you missed them on the other slide, feel free to grab them. I think I have time for questions. Yeah, I think I'm just on time. I can take a few questions. Would love to take a few questions. Wait for the mic.
Great presentation. I really enjoyed learning of all the resilience methods that you have. Quick question on the resiliency. How do you handle against products that are like third party and that release on a certain day, like the PS5? How do you mitigate against situations like bots taking up all of it or running the traffic so we end up getting all the nice dogs saying, hey, we can't find what you're looking for half the time?
Believe it or not, with the amplification on the stage, it's actually a little hard to hear. But you said about third-party dependencies specifically. How are those handled?
Like the PS5 launch, when it first launched, every time we went, it's always just, hey, 404 not found, everyone trying to get it, most of it being bought up by bots. How do you mitigate issues around that?
Well, yeah, I mentioned with the bots, I mean, theoretically, you were getting errors, and I can't dispute your experience, right? But theoretically, they should be like blocking the bots and pulling the emergency lever. The other thing is I know with the front end, they try to cache things they know are going to be popular, so that it's not making a bunch of back-end calls. So, caching the page and everything you need to buy the PS5. Since it didn't work, it's not as strong a story, obviously. I think what would happen there is I could look it up, but there almost certainly was a COE on that, right? If you were getting errors, and that was out there in the marketplace, people were getting errors, there should be a COE understanding what, of the systems that Amazon has in place, what didn't work right, and how do we fix it, and how do we prevent that from ever happening going forward?
Okay. One of the examples you showed with a failover, you had a critical service, but you had one showing for the Relay app that, hey, this is not necessarily as critical. We'll do a failover, see how it happens. Yeah. For chaos testing, chaos experimentation, how do y'all go about or approach for something that is like super critical or potentially even if this app is down, it's dangerous? Like, I'm trying to think of an example, but something where for people, if they're doing their job, it's dangerous if this thing is down. Right, right. So how do you do chaos engineering on that? Yeah. Carefully. No, seriously. So chaos engineering doesn't have to be done in production. The closer you get to production, the better, because that's where the production traffic is and production topographies and all that good stuff. But you're always going to do chaos engineering in a pre-prod test environment before you even go to production. And sometimes that's where it stops, right? You want to maybe simulate traffic. You might want to record traffic and then sanitize it or create synthetic traffic and test. And that's the nice thing about the cloud. You could set up an environment that looks appreciably like your production environment, inject some traffic, do your chaos engineering there, and protect your users. Another thing you can do in production is to set up like a blue-green type deployment. This is where you actually deploy a separate deployment of servers and capacity in the cloud and do the experimentation there. There, you're still affecting customers, but you're only affecting a small % of them. And with the right observability, as soon as you see those guardrails start to go yellow, you dial it back. So that's how you get the confidence to do it in production. So the answer is do it not in production a lot. Do it in production using guardrails and things like blue-green deployments. I was curious because we're in airlines, so it's kind of, if you're doing stuff with planes. Well, just do it, just start out non-production. I mean, that's a no-brainer, right? You're not affecting any production systems. Start out there, you're going to learn a lot.
Thank you for the presentation. So this is Amazon's kind of journey. What would you say to like an organization that says, oh, we're not mature enough for, chaos engineering? And you kind of answered it with his question about like doing it in lower environments and such. But Like, do you have any statistics on like what customers are taking advantage of the FIS?
I don't have statistics. What I can say is that we're hearing that things like fault injection and chaos, those words scare management at certain companies. So, you know, certainly stress when you're talking about this with your management that you want to do this, that chaos engineering is not about creating chaos, even though I think I literally used those words somewhere during my talk. So it's not about creating chaos, it's about uncovering the chaos that's already there. The production is chaotic. We should all know that. There's, you know, user patterns that are unpredictable. There's networking. There's hardware failures. That chaos is there. Unless we do some sort of chaos engineering in some environment, we're not prepared for that. And that's what it's really about, being prepared to be resilient to the chaos that's already inherent in production. So I think that's the messaging.
Thank you.
Thank you, Seth. I was wondering, after a COE, are action items prioritized over other work no matter what? Or is there a process to decide the priority for each item? And if there is a process, who's involved in making the decisions and how are disagreements resolved?
Well, I'm surprised I haven't used this answer yet, but it depends. So it depends on the team. And that really goes back to that two-pizza team and ownership model, right? So they're obligated to deliver those action items. And those action items actually are prioritized in the COE. So it's high priority, medium priority, low priority. So they have dates on them. So it's up to the team on how they deliver those by those dates. If they want to do other work while that's going on and they believe they can do that, that's fine. If they would have put all hands on deck on it, that's fine. That's up to the team. They're just committed to deliver those by the dates that are in the COE. I love questions. I love this.
Hello. Okay.
Hello.
Hey. Great presentation. This speaks a lot to the work that I've been doing the past year on my team and trying to reinforce chaos engineering across all of our app teams. Kind of in the same vein of the last question, what are some pathways or just things that you've seen teams utilize to motivate or incentivize teams to continue to use chaos engineering tools?
Well, nothing motivates like an outage, but that's not something you want to create.
Right. Outside of taking down production.
Like, I know, I mean, working in resilience, it's like, oh, you know, when teams or companies have outages, that's when they come to us like saying, all right, what should we be doing? What did we do wrong? But, you know, that aside is sort of create that awareness without the outage, right? Like, try to show your management and tech leaders, you know, this is our current design. Here's where it's resilient. We think it is. Here's where it's not. And even where we think it is resilient, we don't know. Unless it's actually happened in production, we don't know. We think this will work this way. We think being multi-availability zone means that if there's a failure with this RDS database instance, it's going to fail over and our clients are going to pick up on the new DNS entry. We think that's what's going to happen, but we don't know until we try it. So let me try it. Let me try it in this test environment. I think that's the starting point. All right, anything else? One more question. I want to take one more question, if anybody has one.
Hi,
right.
Seth, over here.
Oh, okay.
Hi, I'm Marissa Horn from Capital One. Thank you for your presentation today. I wanted to go back to the two pizza team. You mentioned, build it, own it, completely agree. But then you also shared that there are some instances where maybe you don't own it. And I was just wondering if you could expound upon those and share some examples.
I'm not sure when I said you don't own it. What did I say?
You said that depending upon the team, there may be things you don't own.
Well, there's certainly things you don't own. So the whole thing about there's a centralized builder tools team, right? That owns all the pipelines and the build tools and all that, right? They obviously don't own that, right? But that's an example of specialized teams creating platforms that you can use. I think what I said was teams are free to use the technology they want, and if they go off the path, right? They pick some wacky technology, they're kind of on their own there. They're not going to get the support from builder tools. They might not be able to use a centralized build system, but it's up to them to make it work. So then they have to decide, they're going to experience some pain of being off the path. Is it worth it to use this wacky technology, whatever wacky technology of the day there is? And I think that's maybe what I was referring to. So the teams get the choice whether to follow the easy path, whether that works for them, or follow the harder path, but they think it's ultimately going to be easier because it's going to give them some technological benefit.
Thank you.
All right, sure. All right, well, yeah, that was the last question I was told, but thank you very much. It was a lot of fun talking with you. Thank you.